with data reduction part. Okay, so let me tell you what is this data reduction. So there are a few types of data reduction and a data reduction part, a complete thing we'll look into. So in nowadays we have this heavy data systems, like the data systems which are heavily loaded with the data, and everywhere we can see the data, and data is getting captured from complete surrounding. Whatever is there with us is able to capture the data, and then so this data set could be big in terms of observations, or it is big in terms of the features also, like we have more columns or both of them. So data mining becomes a tedious in this case, and here what we require is we require only the important features to be considered for the analysis purpose. So complex queries might take a long time to go through this huge data sets, and that's the reason we need some quick alternatives, and that quick alternative is a data reduction. So data reduction consciously do or the categorize or extract the necessary information from a huge array of data to enable us to make the conscious decisions. So that is what is about my data reduction. So let me tell you what is this data reduction is. So data reduction formal definition is data reduction is the transformation of numerical or alphabetical digital information derived empirically or experimentally into a corrected, ordered, or a simplified form. So very difficult to understand these too many words. So this is just, I can say, I transform a transformation of numerically or alphabetically digital information, which I get after the correcting, ordering, and simplifying the data. Correct. So it simply means the large amounts of a data are cleaned, organized, and categorized based on the prerequisite criteria which help us to take the business decisions. So there are few data reduction techniques which we can see. So these data reduction techniques are primarily divided into two methods: dimensionality reduction and numericity reduction. So in a dimensionality reduction, we have so this dimensionality reduction is the process of reducing the number of dimensions. Abhi dimensions kya the? We have already seen the dimension means attributes or a feature, or simply they are columns from our data set. So this dimensionality reduction is the process of reducing these columns or attributes or the features or the dimensions. It means that the attributes or the features of that data set carries as the number of dimension increases, then there is an increase in sparsity. So this sparsity is a critical to clustering, outlier analysis and other algorithms. Sparsity का मतलब क्या है कि जितने ज़्यादा features है आपके पास, जितने ज़्यादा attributes है, dimensions है, those many things are going to create empty data sets also. There may be data missing, so it gives me a sparsity in my data set. So this sparsity is difficult to handle in the case of clustering, outlier analysis and some other attributes, and that's the reason we reduce the dimensionality. And even when we reduce the dimensionality, it is easy for us to visualize and manipulate the data as well. So we have three types of dimensionality reduction. The first is wavelet transform, then we have a principal component analysis and attribute subset selection. So let's look at it each one by one. A wavelet transform is a lossy method for dimensional reduction. Abhi lossy method का meaning क्या है? That after applying this method, our data is lost. आपने कंप्रेशन सुना होगा, डेटा कंप्रेशन, करेक्ट? जैसे कि एमपेग, जेपेग फॉर्मेट से जैसे आप इमेज सेव करते हो, इमेज इज ओरिजिनली इन बीएमपी फॉर्मेट, करेक्ट? व्हेन आई ट्राई टू स्टोर द इमेज इन एमपेग और जेपेग फॉर्मेट, व्हाट हैपेंस इन दोस केसेस? इन दोस केसेस आई रिड्यूस द साइज ऑफ इमेज, करेक्ट? सो आई कंप्रेस द इमेज. How do I do it? I just remove the redundant data from the image and then I try to reduce it. जैसे आप zip फाइल करते हो, तो zip फाइल में क्या करते हो? आपका जो ओरिजिनल डेटा है उसको आप कंप्रेस करते हो, छोटे साइज में कन्वर्ट करते हो, करेक्ट? Now what happens in this MPEG and JPEG compression? दैट इज में लॉसी कंप्रेशन, बिकॉज एमपेग जेपेग को आप रिवर्ट में ओरिजिनल इमेज नहीं बना सकते हो, जो हाई डायमेंशन इमेज है आपकी या हाई क्वालिटी इमेज है. जैसे जनरली यू मस्ट हैव फाउंड व्हेन वी हैव अ इमेज व्हिच वी ट्रांसफर टू व्हाट्सएप में इमेज ट्रांसफर करते समय एज ए इमेज करोगे तो क्या होता है, डेटा रिड्यूस होता है, साइज रिड्यूस होता है, तो हम क्या बोलते हैं, क्वालिटी रिड्यूस हो गया इमेज का, राइट. एंड इफ आई ट्रांसफर इट वाया व्हाट्सएप बट इन द फॉर्म ऑफ डॉक्यूमेंट्स, देन उसका साइज प्रिजर्व होता है, करेक्ट. सो दिस इज व्हाट व्हेन आई डू इट इन द व्हाट्सएप, देयर इज अ लॉसी कंप्रेशन में लॉस हो जाता है इमेज का, एंड दैट्स द रीजन माय क्वालिटी ऑफ इमेज इज डिक्रीज. The same concept, lossy concept, is applicable over here at wavelet transform also. So I say that wavelet transform is a lossy method for dimensionality reduction, where we transform a data vector from one form to another form, correct. The result of wavelet transform can be truncated unlike its origin, thus achieving the dimensionality reduction, right. Then we have this principal component analysis. This method, principal component analysis method, involves the identification of few independent tuples with n attributes that can be represented from the entire data set. What does it mean? It analyzes the principal components of the data set. There must be multiple components in a data set, multiple attributes in a data set, but which are the important or which are the principal attributes or principal components, and those principal attributes are analyzed over here. Then we have the attribute subset selection. In this method, the irrelevant attributes are removed or redundant ones are replaced with the core attributes only. And this is what is called as attribute subset selection. So core attribute subset selection reduces the data volume and dimensionality. So these are my methods of dimensionality reduction. And then we will move to the next method, which was the numerosity reduction, right. हमने ये table देखा था, इसमें one we had is a dimensionality reduction, another we have as a numerosity reduction, correct. So what we do in the numerosity reduction? So this method uses the alternate small forms of data representation. Does it reduce the data volume? So there are two types of numerosity reduction also, which we can see, parametric and non-parametric. So parametric में क्या होता है कि in this method it assumes a model into which the data fits. So data model parameters are estimated and only those parameters are stored and the rest of the data is discarded. Just take example, like when I have a regression model. So this can be used to achieve the parametric reduction if the data fits the linear regression model, correct. And another is a non-parametric. So in this non-parametric method, a numerosity reduction technique does not assume any model. The non-parametric technique results in more uniform reduction irrespective of a data size, but it may not achieve a high volume of a data reduction, which is actually generally done via a parametric one. So there are four types of non-parametric data reduction techniques itself. So these four types are histogram clustering, sampling, data cube aggregation and data compression. Please remember non-parametric के ही चार types है जो आप यहाँ देख सकते हो. Non-parametric, we have this data cube aggregation, clustering, sampling and histogram, correct. So we will look this all non-parametric methods one by one. So the first which I said is a histogram. This histogram can be used to represent a dense, sparse, skewed or uniform data involving multiple attributes, correct. So this is what is done in the histogram. Then we have a clustering. In the clustering, the data set is replaced by the cluster representation, where the data is split between the clusters depending on the similarities to each other within the cluster and dissimilarity to other clusters. So the attributes which are there, or the data tuples which are there in the one cluster are having the similarity with each other, but which are in two different clusters, then they will have some dissimilarity between them. So the more the similarity within the cluster, closer they appear within the cluster. The quality of the cluster depends on the maximum distance between any two data atoms in the cluster. So this is what about my clustering. Then I have a sampling. So sampling is a capable of reducing large data set into smaller sample data sets, reducing it to the representation of a original data set, right? जैसे कि आप कोई मैन्युफैक्चरिंग कंपनी में गए हो and manufacturing company is producing say 1 lakh units of a jar per day. One jar is getting produced, so 1 lakh units of the jar is getting a glass jar, or you can say glass flask is getting produced by the manufacturing unit in a day. Now out of this original data set, how the testing will be planned? Can a complete manufacturing unit do a testing on complete production? Sometimes it is not possible because there must be a high demand in the market also. So what manufacturing company can do? It will select the samples and those samples will be tested. Say जब 1 hour का jar produce होता है, say in an hour 10,000 of jars are produced. So out of this 10,000 jars, 100 samples will be tested. ऐसे कोई strategy होगा sampling का testing के लिए, right? So this is what is my sampling method, correct? So in this sampling we have again 4 types: simple random sample without replacement of sizes, simple random sample with replacement of sizes. I have a cluster sample and I have a stratified samples. So when I'm doing testing, so without replacement का meaning है कि एक sample उठाया मैंने, उसको test किया तो I will keep it aside. With replacement का meaning है कि I pick up the sample, I test it and again keep it in the population itself. Population का meaning क्या है? जो 10,000 jars जो मेरे और flask जो मेरे produce हुए, वो 10,000 flask में again I will keep the sample or I will keep the jar. So that is my with replacement. I have a cluster sampling, with clusters बनाऊंगी मैं और उसमें से sample select करूंगी. And then stratified is with some strategy, with some predefined strategy, I will select the samples. So this is what a non-parametric data reduction technique, correct? Then I have a data cube aggregation. In this data cube aggregation is a multidimensional aggregation, and that uses the aggregation at various levels of a data cube to represent the original data set, thus achieving the data reduction. So data cube aggregation, where the data cube is much more efficient way of storing the data, thus achieving the data reduction besides the faster aggregation operations. So that is my data cube aggregation. The next method I have is a data compression. So data compression involves the encoding and converting the original data into another form of a data which is going to consume the less space, right? So the simple example is image compression. So that is my data compression method. Data compression, the data that can be restored successfully from its compressed form is called as a lossless compression. While where we are not able to restore the original form of a compressed form, so that is my lossy compression. So this is all about my data reduction technique. So let's have a quick recap of what we have seen in a data reduction technique. So there are 2 data reduction techniques. We have a dimensionality reduction, we have the numerosity reduction. In a dimensionality reduction, we have the wavelet transform, attribute subset selection, and a principal component analysis. In numericity reduction, we have non-parametric and parametric method. In non-parametric method, we have seen data cube aggregation, clustering, sampling, and histogram analysis. So this is all about my data reduction techniques. Okay, and then we will move to the last data cleaning or data pre-processing technique, that is my data transformation and data discretization. Okay. So data transformation is transforming a data into one form, from one form to another form. So this a function that maps the entire set of values of a given attribute to a new set of values or the replacement. This is my data transformation. So I have few methods for data transformation. So let's see these methods one by one. We have a smoothing. So this smoothing works to remove the noise from the data, and the smoothing include the techniques of binning, regression, and clustering, out of which we have seen the binning method. Correct. Then I have attribute construction, which is also called as a feature construction. In this method, new attributes are constructed and added from the given set of attributes to help the mining process. I have a aggregation, where the summary or the aggregation operations are applied to the data. For example, the daily sale data may be aggregated so as to compute monthly and annual total amount. Right, that is my simple way of aggregation. This step is typically used in constructing a data cube for the data analysis at multiple abstraction levels. Then I have a normalization, where the attribute data are scaled so as to fall within a smaller range, like range kaise 1 to 1.0 to say 0.1 to 1.0, or 0.0 to 1, or minus 1 to 1. So like this, I have a smaller range for the data. So that will be my normalized data. Then we have a discretization, where the raw value of a numeric attributes like age is replaced by the interval labels. कैसे होंगे intervals? Like age का जो raw value that I may replace with the labels like 0 to 10, 11 to 20, and so on. Or I may have some conceptual age labels like youth, adult, senior, etc. Then we have the concept hierarchy generation for a nominal data, where attributes such as a street can be generalized to a higher level concept like city or country. So this is what about my data transformation. Correct. Now we will see a few methods out of this. So first we will go to this normalization method. So let me explain this normalization method very clearly. So first normalization is my min max normalization. Correct. अब ये मीन मैक्स नॉर्मलाइजेशन क्या है? द फॉर्मूला इज न्यू वैल्यू, ये वी डैश जो है वो न्यू वैल्यू है. सो दिस न्यू वैल्यू इज इक्वल टू ओरिजिनल वैल्यू माइनस मीन, minimum of that value, that column, divided by maximum minus minimum of that column, into क्या है कि जो मेरा न्यू वैल्यू का जो मैक्स है माइनस न्यू वैल्यू का मिनिमम. करेक्ट. Plus new mean. Correct. So like this, I will be having my normalization with min max method. So if I go and see this example, go and look at this example very carefully. We have say income range is from 12,000 to 98,000. ऐसे मुझे income range है, मीन्स मेरा एक income का column है. आई हैव अ डेटा ऑफ से 10,000 एम्प्लॉइज, और उसमें मैंने उनका इनकम का कॉलम रखा है. और वो जो इनकम का कॉलम है उसका रेंज मीन्स द मिनिमम इनकम ऑफ दैट कॉलम इज 12,000, मैक्सिमम इनकम ऑफ दैट कॉलम इज 98,000. अब क्या है कि फॉर एनालिसिस पर्पज आई वांट टू नॉर्मलाइज दिस डेटा टू अ स्केल ऑफ 0 to 1. यहाँ लिखा है ना मैंने, आई वांट टू नॉर्मलाइज टू 0.0, 1.0. करेक्ट. ऐसे मैंने दिस इज व्हाट इज आई थॉट ऑफ. राइट नाउ my now I under the column say there is a person XYZ whose income is $73,000. So how I will map this $73,000 on the new scale of 0.0 to 1.0. So there I will apply formula of this min max normalization. So कैसे अप्लाई किया आपने? अब देखो, मुझे क्या फाइंड आउट करना है? वी डैश फाइंड आउट करना है. करेक्ट. अब ये वी डैश फाइंड आउट करने के लिए व्हाट आई हैव, वी डैश फाइंड आउट करने के लिए आई हैव दिस वी. करेक्ट. अब ये वी क्या है मेरा? 73,600. राइट, वो गलत नंबर है. सो राइट से 73,600 माइनस मिनिमम क्या था मेरे रेंज? 12,000 था. डिवाइडेड बाय मैक्सिमम क्या था? 98,000 माइनस मिनिमम क्या था? 12,000. सो दिस इज ओके. इनटू ब्रैकेट न्यू मैक्स ऑफ ए क्या है? 1. न्यू मीन ऑफ ए क्या है? 0 plus new mean of A. This is again a 0. So this, if you do this complete calculations, I get an answer as 0.716. So जो रेंज था मेरा 12,000 to 98,000, जिसको मैंने मैप किया था 0 to 1 के स्केल पे, ये रेंज पे when I have input at 73,600, it is getting mapped to 0.716. So this is what my normalization using maximum and minimum values of my range, and that's the reason I say it as a min max normalization. When I have a normalization on the scale of maximum minimum value, it is called as a mean max normalization. Then I have this z-score normalization. So in this z-score normalization, I have this mean and standard deviations, correct? So my v dash is equal to v minus mu a divided by rho a. So where mu is my mean of that complete column, rho is a standard deviation of that complete column. So simply a new value will be calculated with the help of this mean and standard deviation, and which is my 1.225 with z-score normalization. And when I go the normalization with decimal scaling, I will be dividing a given value on the basis of value of decimal, correct? A value of the decimal range I will be dividing the original value with, and from that we will get a normalization by decimal scaling. So these are few techniques for normalization. I hope you all have understood this techniques: mean max normalization, z-score normalization, and normalization by decimal scaling. Then let's move to this discretization. Discretization refers to a method of converting a huge number of data values into smaller ones so that evaluation and management of data becomes easy for us. In other words, what we can say, the data discretization is a method of converting attributes values of continuous data into a finite set of intervals with minimum data loss. A very simple for a data discretization, right? So simply data discretization is discretizing or dividing the values into the smaller understandable chunks. That is my data discretization. So we'll understand this with the concept. So suppose I have the attribute of age, and these values are given like this: 1, 5, 9, 4, 7, 11, 14 till 77. Some values I have. तो अभी मुझे इसका डिस्क्रिटाइजेशन करना है. तो कैसे डिस्क्रिटाइजेशन करूंगी? आई विल हैव अट्रिब्यूट एंड आई विल हैव सम क्लासेस ऑफ इट. So discretization may, after discretization, I have some classes like I will be dividing the age with something like child, young, mature, and old. And then those age values I will be plotting into these different categories. Correct. So I have some discretization of a data. Another example for this data discretization is say the statistics of like website visitors, data of website visitors. For example, all visitors who visit the site with the IP address of India are shown under the India country level. All visitors who visit who visit from the IP addresses of US will be shown in the column under the US, right? So like this, I can have the discretization of the website visitors from the different countries, correct? So this is what is discretization. I hope you understood the discretization. So we have some discretization methods like a binning, histogram analysis, clustering analysis, decision tree analysis, and correlation. Correct. So binning, which we have already seen. So we will have a quick recap of the binning. So these, suppose I have some data of prices in the dollars. तो पहले क्या करना था, याद करो हमने बिनिंग में क्या किया था. So we will be deciding like equal. We will be first sorting the data, then dividing it into equal frequency bins, right? And if I do bin by means, smoothing by bin means, then I will be calculating the mean of a complete bin, and all values will be replaced with the mean of that bin. जहाँ पे जैसे आप बीन 1 में देख सकते हो, बीन 1 का ओरिजिनल कंटेंट क्या था, 4, 8, 9 एंड 15. Then I will be calculating the mean of this bean, which is coming as 9. So जो original values थे, those all are replaced with this values. Correct. Similarly, bean 2, bean 3. When I have smoothing by bean boundaries, what I do is every value is replaced with the nearby boundary. Correct. तो बाउंड्रीज को ऐसे ही रखना है, जैसे बाउंड्रीज मेरे क्या थे 4 and 15. सो दिस बाउंड्रीज वैल्यू आई विल बी कीपिंग एज इट इज. और जो अदर वैल्यूज है जैसे कि 8, अभी 8 को नियरेस्ट बाउंड्री कौन सी है, 4 है या 15 है, ऑफ कोर्स 4 है. करेक्ट. सो आई विल बी रिप्लेसिंग दिस 8 विद द 4. Which is the nearest boundary for 9? Again it is 4, so I will be replacing it with the 4. So like this I am replacing with the boundaries. So this is my binning method for the discretization, correct? And the last method of this data pre-processing is generation of concept hierarchy. A very nice concept or very nice method you can say. So in this concept hierarchy, this term hierarchy represents an organizational structure or mapping in which atoms are ranked according to their levels of the importance. In other words, we can say that a hierarchy concept refers to the sequence of mapping with a set of more general concepts to complex concepts. It means mapping is done from the low level concepts to high level concepts. Correct. जैसे कि example ले लो, you take a simple example of our computer science systems, right? A document is placed in a folder in a Windows at a specific place in the data structure, right? So that is my concept of hierarchy. So एक document के अंदर एक document के अंदर एक ऐसे हम रखते हैं, ठीक है? So that is what my concept hierarchy. Correct. The another example we can see over here is say country per state, city and street. इसका मतलब क्या है कि street is embedded in more advanced concept, that is my city. City is aligned with the more advanced concept like state. So the attribute with the most distinct values is placed at the lowest level of a hierarchy, and the complete hierarchy is generated with this. So this is what my concept hierarchy. So we have done with this data pre-processing, in which we have covered data cleaning, data integration, data reduction, and data transformation and discretization. So first we have seen data quality, और उसके मेजर्स देखे थे हमने. आई होप यू ऑल रिमेंबर. सो इट वाज एक्यूरेसी, कंप्लीटनेस, कंसिस्टेंसी, टाइमलीनेस, बिलीवेबिलिटी एंड इंटरप्रेटेबिलिटी. Then we have seen data cleaning, so where we have deal with the missing values, noisy values and outliers. We have seen data integration. तो integration के लिए that is the integration from multiple sources, and we have seen few problems which we have faced, like entity identification problem, remove redundancies and detect the inconsistencies. Then in the data reduction there were two techniques, dimensionality reduction and numericity reduction, data compression. So there were multiple techniques under this, like wavelet transform, say parametric, non-parametric, histogram analysis. So like this we have multiple techniques for the data reduction. And lastly data transformation and data discretization, in which we have seen the data normalization. So how the data is normalized on the scale, so the scale of min max, scale of decimal scaling, like this, and then the data discretization with the concept hierarchy. So this is how we have done with the data pre-processing part of our unit.